let's look at the impact of market weights. And you're going to see some of the same slides that John has already showed you, but the idea of market weights. And it's surprising if you think about market weights. We deal with heavy weights year in and year out, and we deal with significant shifts in weights from summer to winter. That alone should make us aware of the problem, and those of you in production know what it's like, right? Right now you're trying to get weights down, you can't get pigs into pack and plank because you got too many, and weights go up. And damn, the pigs grow faster than they did before, right? So our building's limited. You would argue in the fall of the year, space and feeders are not a limit to growth. That also suggests that the environment temperature is our big limit, and we'll talk about that in a minute. We had earlier all USDA data. This is specifically barrow and gilt. The regression line is 1.4 pounds a year in carcass weight every year. If you follow the regression out 10 years from now with John patients 75% yield, the U.S. average barrow and gilt weight 10 years from now will be 290 pounds or 132 kilo. Average slaughter weight in the U.S. Okay? That means half of them are what? Bigger. By quite a bit. And yes, we're going to get a blip this year, but if you look close, we had a blip in 96, 95 after the drought, when we were short, or after the floods when we were short of corn, and a blip there, but everything says we're going to be heavier. The other thing that happens that confounds this, and again, John did an excellent job, is we have a lot more damn pigs out there. Those of you that have production systems, you know, the number of pigs we keep per market animal, per breeding animal is going up. We have an inventory of about 10.2 kept for market or weaned to finished pigs for every breeding animal in North America. Okay, and you don't build space until you have to, because space costs money. So you fight that. So what are the options? Pretty simple, right? In the United States and even in Canada right now, our options on finishing barns, we'll do either a tunnel barn or a curtain-sided barn. Can find no data that would suggest one is absolutely better than the other. I can find lots of data where one was wrong compared to the other when you screwed it up. And we're going to show you ways that you can screw up either kind of barn. Because the issue becomes, and I said, John set me up on this one, this is heat production by growing pigs. This is sensible plus latent. So this is total heat production by growing pigs. It's based on a literature review that Tammy Brown-Brandel at USDA published. This basically, the lowest line would be the genetics of the 80s. How much heat did pigs 30 years produce? This is sensible plus latent, so it's air temperature plus moisture that they're producing. This is pigs of the 90s. This is where I have to put heat production in my model of ventilation systems to get the barns to work like they work today. And what it is we add every 10 years about 15%, give or take, total heat output from our growing pigs. Okay, it's a big number when you start looking at it. And it is not a recent phenomena. This is heat production by ad libitum fed growing pigs. This is heat output by fasted pigs. 1936, 1974, 1984, and 2000. The underlying metabolism of the pigs is faster, is better, if you will, and part of it is because they have a higher mass of lean. And the turnover of lean, what generates a lot of the heat? He talked about 20% of the intake or 25% of the feed intake energy is for maintenance. Where's the rest go? Deposition of lean generates heat. And I'll look to John. Deposition of fat doesn't generate much heat. Doesn't spin off ATPs very well off the Krebs cycle. What spins ATPs? Deposition of muscle. So heat output is a huge component that we have to think about. And now, if we go back, the data in the literature stops at 220 pounds or 100 kilos. And now we're going to start talking about a 300-pound pig or a 300-kilo pig. In thermal neutral conditions, approximately 2/3 of the heat produced is air temperature, 1/3 of the heat is moisture in the air. Moisture that's associated with urine, that's associated with respiratory air, that's associated with drying the slats, all of that. Best guess is at today's sale weights. When we get ready to sell our first cut out of a barn, we're somewhere around 800 plus BTU per pig per hour of air temperature that we have to deal with. So I got a 1,200 head room times 800 is 960,000 BTUs of heat. That's 4 LB whites nonstop that we got to deal with. Now, if we're going to add 10 pounds, we're further up on the heat increment. And that has some real challenges for us. Because, number one, we have more heat and the pigs are bigger, we run our barns too warm. There is a small and not very fast accumulating body of evidence that suggests the upper critical temperature on our pigs is lower today by as much as 7 degrees from what has been published in the literature previously. And it would make sense, right? Producers think, well, the pig is leaner, therefore we got to run the barn warmer because they don't have fat for insulation. But in fact, they're generating heat. And the best way to explain that is I tell producers, think about your teenage sons and daughters. When they hit 15 and 16 and they're in stride on growing and eating everything in the house, do they ever get cold? It can be a blizzard outside and they're out there in flip-flops, right? I'm not cold, Dad. What you have to think about is the barns we're managing today, we have barns full of teenagers. And they really are, because they're approaching maturity and they're laying deposition. They have teenage behaviors, which is all that it implies. But heat production is also, as a teenager, huge amounts of heat. That would suggest heat is a bigger deal than we've ever thought about in the past. Summer heat relief will become more important, especially as global warming approaches. So we get bigger pigs, more heat, and our outside air conditions are warmer. We will have to deal with heat in a better way as we go to heavier weights. It also means what in all our barns? Doesn't matter what we use because we run our ventilation with a probe that measures temperature, doesn't it? We're going to go fly through ventilation stages sooner. And many of you are aware of that. The other side of that, the one that all of you are asking today, is what should my set points be in cold winter when I don't impact feed conversion, right? How cold is cold before feed conversion takes another pound of feed? Don't know the answer on that one. There is no published data that I can find to work with, but I would suggest it's cooler than many of you think because of this absolute amount of heat we're putting out. The pig heat is a real issue and will be a very big issue as we go to heavier weights and will impact everything we do. Looking at our barns for heavier weights, we've got two options worldwide, full or partial slats. The U.S. is almost exclusively full slats, other than the Smithfield barns in Iowa, which are partially slats. The U.S. and most of the North American industry is full slats for one logical reason. Never again will I have messy pens. The older ones of us in the room that remember partial slats will not let them happen. There is an interest in going to partial slats because of heat removal. I was part of a team funded by Pork Board to look at alternative housing, what we call a green barn here at the University of Minnesota with Larry Jacobson leading the effort. We looked at what would happen if we built a partially slatted barn and geotherm cooled the floor and pulled heat out. Partial slats have less emissions than full slats, because if the partial slats stay dry, you have less surface emitting greenhouse gases into the atmosphere. How do you keep them dry? You got to make the floor cold in the summer, don't you? Make the floor cold, you got a geotherm. So far we haven't found anyone that can afford to do it. It's still fairly expensive, but the idea is there. The next issue on housing, on bigger pigs, big pens or small pens. You want to have a real interesting debate with people is should I build a big pen barn or a small pen barn? Big pen barns typically in the U.S. Are anywhere from 100 pigs in a pen to some barns that still use auto sorters with 600 in a pen. Small pen barns are almost exclusively 25 to 33 pigs in a pen. So what about pen size? What do we know about pen size? Excuse me. Not much, other than it works. The published data on the impact of group size, and you cannot separate group size, number of pigs in a pen, from the dimensions in a pen. So is it a bigger pen, or is it more pigs in the pen? They absolutely have to go together. But what do we know? There's 2 reviews have been published on the topic. Basically, they say no difference overall in variation in gain in feed conversion or after 80 pounds in feed intake or daily gain. There is a slight tendency during the late nursery and early grower for large group pens, we're talking 100 in a pen, to be just a little bit slower. But those of you that have large pens all know what? You can load trucks a lot easier, can't you? Because they're used to moving. And you get fights. The biggest issue with large pens is what? The people in the barn. If you've walked many barns, some people, have difficulty in large pens. They want to do chores the alley method. If I can just walk the alley and the pigs are all alive, I'm okay. And in a large pen, it's not easy to tell, but they still don't go in the pen. So large versus small pen is probably not an issue, except here. There, I can find 2 published pieces of information on heavy weights and pen size that suggests if we have large pens and we go to heavier weights, physical injuries, lameness may increase. And you might be able to see some of that. This one probably depends partially on the layout of the pen, whether the feeder sits in the pen and the pigs can racetrack around it, or whether there's gating so the large pen is a U-shape, or some of that. But there is some evidence to suggest, especially if we go to heavier weights, there is some increase in possibility of injuries and lameness. Well, how much space do we give the pig? And this one is actually pretty simple to answer, and it's been worked out, and the data holds very true. We talk about the allometric equation for space. Space is a constant times a function of body weight. And it looks like this. This is the response to daily gain. If we set the best treatment to 100% response, the treatment that has the most space to 100%, and then plot it again, the paper that Harold Gonyou led the team on, funded by Pork Board, that looked at it, says we reach the break point on space when this constant is 0.034 in metric numbers. We'll give you some pictures in a minute, because 034 doesn't mean anything, because you don't build barns with a constant 0.34. You build barns at 7.2 square foot a pig, and we'll convert that. But when we crowd pigs, 2 things happen, and it really isn't clear which happens first. Notice the break point on daily gain is 0.034. The break point on daily feed intake is 0.034. When we crowd pigs, they eat less and grow slower, with almost never a penalty on feed conversion. Right? And many of you are aware of that in your production systems there, that the R-squared on this one is 0.04. Not much relationship between space and feed conversion. So, let's look at the number. If we gave pigs the space that maximized feed intake and daily gain, whether you want to do it in metric or imperial units, this is how much space we would have to give pigs in our barns. And what that says is you say you've got a 280-pound sale weight. What that means is what? You're topping pens at 255 when the barn is 255, 260. It says if you top pens when all the pigs in the barn average 240, you need 8.3 square foot a pig. Is anyone in this room giving your pigs that much space? Yeah. I mean, I'll show you why in a minute, but that doesn't happen. If we go to heavier weights and we add the 20 pounds or 30 or 40, this is the kind of space we need if we wanted best individual pig performance. It's a really big number up there. So let's look at this space. And I've put here this point, and you want to follow the metric side. So this is remember the constant requirement is 0.034. This is 0.024, what it looks like in a pen. Now we would agree that's a little crowded. That's probably what all your finishers look like this week because you're calling ahead and you can't get pigs in the packing plant yet. And a lot of you are running almost this tight right now. Here's 0.03 though. That sure looked like a lot of barns that are out there. This is what you would have to look like. These pigs are a little lighter, but think about how they're filling the space around them. That's how much space you would have to give individual pigs if you expected pigs to have the best pig performance in a barn. Quite a bit of difference. So, here's what we know. Based on the published literature that Harold's group that I was part of looked at, says on full slats, each 3% change in space is a 1% change in gain in feed intake. Okay? 3 to 1, you can tell what you guys do real fast as working in the business. With no predictable impact on feed conversion. So it looks like this. As part of a different study I was involved in with Pork Board, we surveyed the industry in about 2005, 2006. The average space given to finishing pigs at stocking was 7.2 across the U.S. And that didn't matter whether it was in North Carolina, Oklahoma, Iowa, or Minnesota at 7.2. So here is the requirement based on the K value. This is how much you give up in potential gain. Now this give up in potential gain is based on the total gain from placement at approximately 50 pounds or 22 kilos to first pull. Because the published literature we had to work with didn't have all the wait periods, so we could not do a break point on when did it hurt. So what this says is if you stock a barn at 7.2 and the requirement is 8 and you top pens at 225 pounds, your closeout, you gave up 3% potential daily gain. Okay, because of the pigs couldn't eat at the end. Now that all happened at the end, but the overall number was 3%. As we go to heavier weights, this is what it's going to look like. Because most of you have done exactly that. You've used 7.2 as the stocking density in your barns for the last 20 years. And you've added 30 pounds in sale weight. So you have already made this move because of cost of facilities. But this is what, as we go to heavier weights, unless we change stocking density, what we will give up on pig performance because of crowding. Those that have partial slats, the impact of space is worse because now the pig is always dirty. He has no place to go find a clean area to lie down. So the first increment of crowding affects them worse. Let's go to the next one that impacts us. And again, John did an excellent job of setting me up on this one because he talked about a study where feeder space was limiting. Let's talk about feeders and feeder space and how big a number it really is. So we're going to go to just a grow finish barn, 2.6 turns a year, those kinds of numbers, 230 pounds of gain. And we can do a 50 wide barn with 33 pigs per pen, which would be 15.1 meter wide, or 12 meter wide barn, 40 wide barn with 26 pigs in a pen. If our feed back when we thought it was expensive at 225, That's how much feed goes through every feeder every year in dollars. If I change feed conversion 0.03 units because of a feeder decision, that's how much money per year per feeder I have to work with. Let's put it in today's dollars. $325 a ton. Every feeder in your barn today is now $18,000 that you're controlling with the feeder. Getting the feeder right is suddenly really a big number, isn't it? When you think about it. So what do we know about right? Well, we know when we put feeders in a barn, they're a fixed size. And if they did a really good job, 304 stainless, and welded them really good, they last a really long time. So what we have here is a site. Feeder was installed in 1995. I took the picture in 2007. Do you think that pig has access to feed? I was at this site because the people in the barn said we need new feeders. The ownership said what? They're 304 stainless and they're not broken. You know, so you get in that argument. But what's the limit on performance? Right there, that pig's difficulty in eating. 3 common types of feeders we're going to talk about today. We've got wean to finish, we've got the dry feeder, and we've got basically the Crystal Springs wet dry. The one I'm not going to say much about is tube feeders. Number one, because there's no good research for an obvious reason. Second, my best guess is numbers like that, long term, from the tube, versus the other kinds of feeders for a whole host of reasons. So what do we know about feeders? Number one, we know the physical dimension that's most critical on a feeder is shoulder width. You can only get so close to your buddy, and then there's a shoulder. And Petherick's equation on shoulder width, which works out very well, says this is the predicted width of the shoulder on an average pig. Now that doesn't account for an impovest or an immune castrated male that would have a bigger shoulder yet. But it says as we go heavier, shoulders get pretty big, don't they? And if I need room at a feeder, I can't use this number because that's tight to tight. So the correct number is 1.1 times the shoulder width. As we go heavier, we have to start getting 14-inch minimum widths per feeder hole. Okay? The other one that's important is right here. As we go heavier in nurseries, what's every nursery feeder still sold in the United States? 6-inch by 6-inch hole. Hasn't varied at all in the United States. 6-inch by 6-inch hole was good for when we took pigs out of nurseries at 35 and 40 pounds. Not 60 and 70 pounds. We need to be looking because that limit isn't just sale weight related, it's management related per phase. But as we're up here, we're talking feeder holes that need to be a minimum of 13 to 14 inches. So, what do we know about the other critical dimensions? Harold Gonyou had a student that he worked with. In 1997, they published some numbers using 90 kilo pigs or 200 pound pigs, looking at critical dimensions. And he said there's 3 critical dimensions on a feeder. The first one is the depth, from the front lip to where the feed is presented with the agitator plate. He said should be a minimum of 8 inches up to 12 inches. And he said for a 90 kilo pig, the best depth is 10 inches. Well, a 90 kilo pig, though, is only 210 pound pig. So 10 inches isn't very much, is it, all of a sudden, when our average weight could be 290 in a barn. And I'll show you some dimensioning in a minute. The second one, lip height, mostly refers to wean to finish feeders and the little pig being able to eat. It's not as critical on bigger pigs. And the final one is the shoulder width that we've talked about. So, here's the real world of feeders. I'm in this barn this summer, and I was with the field man the day they marked the first pig out of the pen for sale. So that pig is going on a truck in about 2 hours. Okay? That's a 6-hole feeder with 15-inch holes. If that was a 6-hole feeder with 12-inch holes, how many pigs would be at the feeder? Be one less for sure, and maybe 2 less, wouldn't it? So as we start going to heavy weights, what do we have to do? We have to be thinking heavier, or feeders are bigger. And yes, you have feeders in your barn today, but those of you that are thinking of building, you always base your feeder decision on today's needs, don't you? What will fit on my feeder today, not what's going to fit my needs 10 to 12 years from now. Because you expect the feeder to last 10 to 12 years. That's why you buy them 304 stainless welded. I'm arguing that we need to be looking at making feeders bigger because it is a critical limit. So have you gone out with a tape measure and measured feeders? You want to get a real interesting exercise, do it. So here's one that's 10 inches from front to back, 15-inch hole, nice lip height. Another dimension that hasn't been researched, but the more I work in it, the more I'm convinced it's there, is before you come to the upslope, what's the minimum distance you got to have on the flat pan so the pig can effectively work this so that you can keep the feeder adjusted to minimize feed waste? I think it's 6 inches. Okay, is my minimum number, or 155 millimeters, is my minimum number, based on my experience, that it needs to be that. So, here's one I was in recently, the feed holes, you know, it's a 12-year-old feeder. Feeder's still good, but the feed hole's only 12 inches. It makes maybe 9 inches, but the bottom, and it sort of works, but he knows he's going to have some what he calls dead holes as he gets slaughter weight. The other issue you get, remember we talked about 10 inches as what Harold said for 90-kilo pig. We know feeders get limiting when they become mirrors. Okay? When you can see yourself in the feeder, what's that mean to the pig that's been trying to eat? He's pushing too hard to get at the feeder. And if we go to heavier pig, physical dimension of the head gets bigger. Function of growing. That would argue that I need at least 12 inches long term in the future for the space in the feed hole to avoid some of this. Shared this talk last week with Floyd McKeith, the meat scientist from University of Illinois. He was part of the pork quality audit that Pork Board did several years ago, looking at the defects in our products coming into the food chain, and the jowl and the head injuries. He said that explains why 4% of all the pigs we see in the pork quality audit had problems because the feeders were dimensioned wrong. And if we go to heavier weights, this becomes an even more critical. Here's how not to do it. Okay? Went to this farm. I was there for a different reason. And why did, and you asked, why did you put the feeder in? The feeder held a lot of feed. Didn't say it fed the pigs, so you start looking. It's a little short, but it's only 3 inches there, and there's a lip on top. If you look close, a brace across the top. So for the pig to access the agitator, they had to run the agitator wide open. And what's the complaint on the barn? My closeouts are always bad at the barn. Well, yeah, the pig physically couldn't eat and are adjusted. Or this one. This is one where they had a feeder. It's only a 10-inch wide hole, and they'd converted to wean to finish, so they'd welded something in, and now they were selling to Triumph. And you can see, you tell me if that's a quality eating experience for the pig, because that's what we're talking about, quality eating experience. The other beef I have with feeders is the companies that add a hole for every 10 inches of feeder, because you got a gate that's a 50, a 60, or 70-inch gate, and you buy a replacement feeder. So do you want it a 4-hole or a 5-hole? They'll make whatever you want, because they're good welders, right? So you can start with a hole this size, and when you're done, it's got more holes, but they're smaller. So we can't just count the number of holes. We have to talk about the quality of the hole. So what are we talking? When we get the feeder correct, and notice we've added something called quality feeder. The data all says you could put 8 to 10 pigs per hole when you get it right. Some of you insist on wanting to dimension feeders in inches. I want 1.7 inches per pig. But if there's a metal divider, it's an all or none dimension. Either you can get your head in the hole or you can't. You can't slide over. But if you want to get to a dimension, you can do it. If you have a 15-inch hole and you insist on 1.7, you're at 8.8 pigs per space. So they actually cross-check. But that's the number. Wet-dry, because pigs eat faster on wet-dry feeders, you can crowd them a little more. The data, actually the European data says 17 pigs per space on wet-dry, but I'm not ready to go that high. And if you feed pellets, because they eat faster on pellets than meal. Now, we don't know if that's a definition of a good pellet or a bad pellet, but the data just said pellets versus meal. I'm going to end here because we've already to stay on time. A conclusion is the place where you got tired of thinking. So I'm tired of thinking about pigs to heavyweights because it's going to pose a whole new set of challenges on how we ventilate the barn, what do we do for heat management, what do we do for drinking, what do we do for stocking density in the barns. Do we have to ultimately put more barns up, or do we just put more pigs per barn and suffer the performance penalty because financially it cash flows better? And those answers have yet to be fully determined.